Step outside on a clear night and look up. You see a canopy of ancient light, a seemingly crowded ceiling of shimmering stars. It feels intimate, as if the cosmos is a grand tapestry draped just beyond the atmosphere. We have spent millennia projecting our earthly myths onto that false proximity, connecting the dots because the human brain is hardwired to find structure in the chaos. But the sky above you is lying. What you are witnessing is an optical illusion born of our biological limitations. It is a comforting, localized deception, masking a reality so profoundly vast that it defies the architecture of human thought. Consider the moon. It sits casually in our night sky, a familiar companion. Because we can see its craters with the naked eye, you might unconsciously imagine it as a neighboring suburb, a physical place just a short conceptual distance away. But the emptiness between the ground beneath your feet and the lunar surface is a staggering chasm. If you were to gather every single other planet in our solar system, Mercury, Venus, Mars, the massive gas giant Jupiter, the sprawling rings of Saturn, Uranus and Neptune, and you lined them up side by side, edge to edge, they would all fit seamlessly into the empty void between Earth and the Moon. There would even be a few thousand miles left to spare, and that is merely our closest celestial neighbor. That is the absolute shallowest end of the cosmic ocean, a distance so localized it barely registers on the mathematical ledger of the universe. To truly grasp what lies beyond, we must measure the abyss in light. Light is the fastest entity in the physical universe, tearing through the vacuum at a velocity that could wrap around the circumference of the Earth 7 times in the span of a single human heartbeat. Yet out there in the deep dark, even light is agonizingly slow. It crawls across the cosmic architecture. If you possessed a vessel capable of traveling at that ultimate speed, pushing the boundaries of known physics, it would still take you over 4 years of unbroken travel just to reach the very next star. That is 4 years of plunging through a freezing nothingness where human intuition shatters and distance morphs into a kind of mathematical horror. The universe is not a bustling metropolis of stars. It is an unfathomably vast, indifferent desert, punctuated by microscopic, isolated islands of matter. To comprehend the actual scale of the cosmos is to confront our own terrifying isolation. It requires us to abandon the psychological comfort of human scale and look directly into a void that does not know we exist. If you are prepared to shed the illusions of the night sky, if you seek to understand the cold, magnificent mechanics of reality and the true nature of the dark, subscribe and join us on this journey. We are going to leave the shallow waters behind, pushing past the boundaries of our localized existence to measure the exact dimensions of the abyss. We are biological creatures bound to a very specific set of parameters. For hundreds of thousands of years, the survival of our species depended entirely on understanding immediate, localized space. Our ancestors needed to calculate the trajectory of a thrown spear, the distance to the nearest river, or the proximity of a predator hiding in the tall grass. The human brain evolved as an exquisite biological supercomputer optimized for a radius of perhaps a few dozen miles. We are intimately wired for linear progression, for walking paces, for the scale of trees and mountains. We understand miles and kilometers because we have felt them in our muscles and measured them with our exhaustion. But the moment we attempt to apply this grounded terrestrial intuition to the architecture of the cosmos, our minds simply misfire. The brain encounters a spatial reality it was never designed to process, and so it does what any overloaded system does. It creates an abstraction. It compresses the incomprehensible into a flat, digestible image. This biological limitation dictated human cosmology for millennia. When the ancients looked up, they did not see a terrifying abyss. They saw a roof. They saw a mechanical, predictable dome that operated precisely for our benefit. Claudius Ptolemy, the brilliant mathematician of antiquity, formalized this intuition into a grand, comforting system. In the Ptolemaic universe, the Earth was the heavy, immovable anchor of reality. Encasing us were massive, transparent, crystalline spheres, nesting within one another like the gears of a titanic clockwork. The moon, the sun, the planets, and finally the fixed stars were all fastened securely to these spheres. It was a perfectly enclosed terrarium. The distances were large, certainly, but they were manageable. They were finite. The universe was a room, and we were sitting safely in the center of it. This model survived for over 1,000 years, not just because the mathematics seemed to predict the movement of the planets, but because it offered profound psychological safety. It shielded humanity from the horror of the infinite. The dismantling of this protective dome was not a sudden explosion, but a slow, agonizing fracture of human ego. When Nicholas Copernicus finally proposed that the Earth was not the anchor of creation, but merely another wanderer orbiting the sun, he did not just shift a map. He evicted humanity from the center of existence. Yet, even Copernicus could not break free from the illusion of a cozy universe. He still imagined the stars enclosed within an outer shell, just a bit further away than previously thought. It was Johannes Kepler, analyzing the meticulous, agonizingly detailed astronomical records of Tycho Brahe, who began to pry the lid off the terrifying box. Kepler realized that planets did not move in perfect divine circles, but in warped, stretched ellipses. The mechanics of the heavens were not the smooth turning of perfectly engineered wheels, but the restless, uneven swinging of massive rocks chained by invisible forces. And to make this orbital mathematics work, the physical spaces between these celestial bodies had to be violently expanded. The solar system was suddenly unmasked, not as a tight cluster of spheres, but as a sprawling, mostly empty wasteland. But the true death blow to our terrestrial intuition came from a concept much more elusive than orbital geometry. It came from the realization that reality itself is delayed. For most of human history, it was assumed that light was instantaneous. If an event occurred across the universe, it was believed that the visual confirmation of that event arrived everywhere simultaneously. The present moment was universal. This illusion was shattered in the late 17th century by a Danish astronomer named Ole Rømer. Rømer was not trying to break the universe. He was simply trying to improve the accuracy of maritime navigation by meticulously tracking the eclipses of Jupiter's moon, Io. Night after night, year after year, he watched through his telescope as the tiny moon vanished behind the massive shadow of the gas giant and then reappeared. Rømer noticed something deeply unsettling in his ledger of times. When the Earth, in its own orbit, was moving closer to Jupiter, the eclipses of Io seemed to happen earlier than his mathematical models predicted. Conversely, when the Earth was swinging away from Jupiter to the far side of the Sun, the eclipses occurred later and later. The celestial clockwork was completely out of sync. Rømer realized that the timing of the moon had not changed at all. What had changed was the distance the light from that moon had to travel to reach his telescope. As Earth retreated across the cold gulf of the solar system, the image of Io had to cross an ever-widening ocean of space, and it took time to cross that ocean. This was a catastrophic revelation. Light had a speed limit. It was not a divine, instantaneous flash, but a physical phenomenon that had to drag itself across the void. The implications of this are so profound that even today we struggle to accept them in our daily lives. Because light takes time to travel, it means that every time you look out into the universe, you are absolutely blinded to the present. You are only allowed to see the past. Imagine standing on a dark highway, shrouded in a dense, freezing fog. In the distance, you see the headlights of an oncoming truck. But because of the strange physics of this fog, the light from those headlamps is creeping toward you at a snail's pace. By the time the light hits your eyes and your brain registers the presence of the vehicle, the truck is no longer where you see it. It has moved. Its ghost remains painted on the fog, while the physical, crushing reality of the machine is already somewhere else entirely. This is the exact mechanic of our cosmos. When you look at the sun, you do not see the sun as it is right now. You see a ghost that is 8 minutes old. If the sun were to suddenly extinguish, plunged into absolute blackness this very second, humanity would not know. We would continue to walk around in the daylight, oblivious for 8 full minutes, bathed in the phantom light of a star that no longer exists. Our intuition screams that the things we see are happening right now, but the universe operates on a relentless lag. Every star in the night sky is a delayed broadcast. Some of the twinkling lights you perceive are ancient echoes from stars that burned themselves out millions of years before humans even learned to walk upright. You are staring at a graveyard of optical ghosts, utterly disconnected from the current physical state of the galaxy. Yet even knowing that light takes time to travel, the early astronomers still had no concept of the true distances involved. They knew the solar system was massive, but the stars remained just points of light glued to a distant background. To finally measure the chasm between us and the stars, science had to rely on a terrifyingly simple geometric principle called parallax. Parallax is the visual shift of an object against a distant background when viewed from two different positions. If you hold a finger in front of your face and close one eye, then switch to the other eye, your finger appears to jump back and forth against the wall behind it. The closer the finger, the larger the jump. Astronomers realized that if they measured the exact position of a star in the sky and then waited 6 months for the Earth to swing to the complete opposite side of the Sun, they would have two viewing positions separated by nearly 200 million miles. By measuring how much the star appeared to shift against the deeper background of space over those 6 months, they could calculate its exact distance through trigonometry. It was an elegant plan. But generation after generation of astronomers aimed their telescopes at the heavens, recorded the positions of the stars, waited 6 months, and found absolutely nothing. The stars did not shift. They remained entirely static, frozen in place. For decades, this lack of parallax was a crisis. It suggested either that the Earth was not moving at all, throwing science back into the Dark Ages, or that the stars were so unbelievably, horrifically far away that even a shifting baseline of hundreds of millions of miles was too microscopically small to produce a visible angle. Human intuition prayed for the former. The universe delivered the latter. It was not until the year 1838 that a German astronomer named Friedrich Bessel finally possessed a telescope sensitive enough, and the obsessive patience required, to measure the parallax of a star system known as 61 Cygni. The shift he observed was so vanishingly small, it bordered on the edge of human perception. It was the equivalent of trying to measure the width of a single human hair from over a mile away. But the math was undeniable. When Bessel ran the numbers, the resulting distance broke the back of the astronomical community. 61 Cygni was not millions of miles away. It was not billions of miles away. The numbers generated by the parallax equation were so absurdly large, with zeros trailing off the edge of the ledger, that standard terrestrial mathematics became entirely useless. To describe these distances, astronomers had to invent a new metric, a yardstick forged from the speed of light itself. They called it the light year, the distance that the fastest thing in reality can travel in 365 days. A single light year is roughly 6 trillion miles. Bessel discovered that 61 Cygni was over 10 light years away. To put that catastrophic distance into perspective, imagine shrinking the massive burning sphere of our sun down to the size of a standard grain of sand. If the sun is a single grain of sand resting on your fingertip, the Earth is a microscopic speck of dust orbiting it just a few inches away. Pluto, the frozen edge of our planetary system, would be another speck floating perhaps 10 feet from your hand. On this drastically reduced scale, where the entire solar system fits inside a small room, how far away do you think you would have to walk to place the very next grain of sand representing the nearest star to our sun? You would not step outside the room. You would not walk down the street. You would have to walk for over 4 miles carrying that single grain of sand before you found the next star. And between your fingertip and that distant grain is nothing. A brutal, freezing, irradiated vacuum. This is the architecture of our immediate neighborhood, a handful of scattered sand grains separated by miles of absolute emptiness. When you look at the glittering night sky, your brain artificially condenses these isolated outposts into a dense, shining neighborhood. It stitches together a community that does not exist. The intuition that keeps us alive on the surface of the Earth is fundamentally incompatible with the truth of the void. We are not citizens of a crowded galaxy. We are castaways stranded on a microscopic speck of dust, quarantined by distances so severe that they isolate us from the rest of creation in ways we are only just beginning to truly calculate. The deeper we peer into our telescopes, the more the comforting walls of our ancient terrarium dissolve, leaving us exposed to a geometry that is hostile to life, hostile to meaning, and utterly indifferent to the lonely watchers in the dark. The isolation of our stellar neighborhood is only the prologue to a much deeper, more systemic terror. When we finally map the layout of the stars surrounding us, we realize they belong to a single, localized structure, the Milky Way. It is not merely a collection of lights, but a swirling, violent disk of stellar shrapnel, bound together by the invisible tyranny of a supermassive black hole at its core. This black hole, a gravitational grave with the mass of 4 million suns, crushes space and time into an infinitely dense point, anchoring the orbital mechanics of perhaps 400 billion stars. To comprehend the physical footprint of this single galaxy, we must again rely on the speed of light. To escape the gravitational grip of the central monster and travel from one edge of our galactic spiral to the exact opposite side, a photon of light must fly continuously, unbroken, for 100,000 years. When the light we currently see from the stars on the far rim of our galaxy began its journey, human beings on Earth had not yet learned to build a fire or forge a blade. We were huddling in the dark, entirely unaware of the titanic, slowly rotating pinwheel of radiation in which we were embedded. And yet, for the vast majority of human history, the greatest minds in astronomy operated under the assumption that this colossal, spinning disk of stars was the entirety of the universe. It was an island of light surrounded by an infinite, featureless ocean of black. There was no mathematical or observational reason to suspect that anything existed beyond the borders of the Milky Way. The cosmos was simply our galaxy, suspended in an eternal void. That comforting, localized paradigm was violently shattered in the winter of 1995 through a scientific gamble that fundamentally fractured our understanding of reality. The director of the Space Telescope Science Institute, Bob Williams, made a decision that many of his colleagues considered a catastrophic waste of time and resources. He controlled a portion of discretionary time on the Hubble Space Telescope, a billion-dollar observatory orbiting above the distorting atmosphere of Earth. Rather than aiming this unparalleled instrument at a known star, a glowing nebula, or a fascinating planetary body, Williams ordered the telescope to stare into absolutely nothing. The chosen target was a microscopic patch of sky in the constellation Ursa Major, near the handle of the Big Dipper. To the naked eye, and even to the most powerful ground-based observatories of the era, this specific patch of space was completely dead. It was a blank black canvas, carefully selected because it was devoid of any bright stars, devoid of nearby gas clouds, and seemingly devoid of any matter that emitted radiation. It was a pinpoint of absolute darkness. The plan was to lock the telescope onto this empty black square and leave the camera shutter open, cumulatively collecting light for over 100 hours, spread across 10 consecutive days. To understand the sheer madness of this experiment, you must understand the mechanics of how a space telescope operates. Hubble does not take a quick snapshot. It collects photons, the fundamental particles of light, essentially dropping them one by one into the electronic buckets of its charge-coupled devices. Staring into the deep black, the telescope was attempting to catch light so profoundly exhausted, so vanishingly faint, that it was the equivalent of trying to confirm the existence of a distant rainstorm by waiting out in a desert to catch a single drop of water every few hours. Think about the physical journey of those specific photons. They were born in the nuclear furnaces of primordial galaxies, forged in the violent collisions of ancient, hyper-compressed hydrogen. They blasted out of their home systems and traveled across the expanding void for 10 billion years. They passed through the silent graveyards of dead stars, skimmed the event horizons of rogue black holes, and crossed oceans of absolute freezing nothingness. For 10 billion years they did not strike a single atom. They were the loneliest messengers in the universe, flying through a cold, silent dark, until finally they plummeted into the upper atmosphere of Earth, crashed perfectly into the polished beryllium mirrors of the telescope, and triggered a microscopic electrical charge on a silicon detector. When the final image, known as the Hubble Deep Field, was assembled and processed, it did not reveal an empty void. In that tiny microscopic pinpoint of sky, a patch of darkness roughly the size of a single grain of sand held out at arm's length against the night sky, the telescope captured the glowing silhouettes of 3,000 entire galaxies. They were scattered across the image like crushed jewels on black velvet. Some were massive, elegant spirals similar to our own Milky Way, while others were chaotic, bloody train wrecks of galactic collisions, twisted by brutal gravitational tides. Each one of those 3,000 smudges of light was an entire island universe, containing hundreds of billions of its own stars, its own solar systems, its own planets, and its own endless stretches of empty, terrifying space. And all of them were crammed into a sliver of the sky that we previously thought was empty. The mathematics of this revelation are almost entirely toxic to the human mind. If a patch of sky the size of a grain of sand contains 3,000 galaxies, then we must multiply that microscopic sliver by the entire spherical area of the sky wrapping around the Earth. When astronomers run this cold, merciless calculation, the resulting numbers dissolve our sense of significance into absolute zero. The observable universe, the sphere of reality whose light has had enough time to reach us since the dawn of creation, contains an estimated 2 trillion galaxies. 2 trillion isolated islands of light, floating in a staggering abyss. If you were to count one galaxy every single second, without stopping to sleep or eat, it would take you over 60,000 years just to tally the celestial archipelago. And within each of those 2 trillion galaxies, there are hundreds of billions of stars, each a churning nuclear reactor dictating the physics of its own localized solar system. The sheer volume of matter is overwhelming, but it is the architecture of the empty space between that matter that reveals the true, terrifying nature of the cosmos. Gravity is the ultimate architect of the abyss. It is the invisible scaffolding upon which the universe hangs its fires. Galaxies do not drift randomly through the void. They are chained together by immense gravitational rivers. They pull upon one another, merging and swarming into massive structures called galaxy clusters. The Milky Way, along with the Andromeda Galaxy and a few dozen smaller dwarf galaxies, belongs to a localized cluster appropriately named the Local Group. But even this cluster is merely a microscopic cog in a much more terrifying machine. Our local group is being dragged, relentlessly and inevitably, toward the center of a colossal superstructure known as the Laniakea supercluster. Laniakea is a Hawaiian word meaning immense heaven, and it is a structural monster. It spans 520 million light-years across and contains over 100,000 galaxies. When we map the movement of these galaxies, they do not look like static objects in space. They look like glowing biological fluid draining down a cosmic sink, flowing along invisible filaments of dark matter toward a central gravitational anomaly known as the Great Attractor. The mass required to physically drag 100,000 galaxies across hundreds of millions of light-years of space is a number so gravitationally severe that it threatens to break the mathematical models used to calculate it. Yet, for all the unimaginable mass concentrated in these superclusters and cosmic filaments, they represent only a fragile, luminous web strung across a realm dominated by nothingness. If the superclusters are the structure of the universe, the voids are its true masters. Between the glowing threads of the cosmic web lie regions of space that are profoundly, terrifyingly empty. The most haunting of these dead zones is the Buta's Void. Located nearly 700 million light-years from Earth, it is a roughly spherical region of absolute desolation measuring an incomprehensible 330 million light-years in diameter. To understand the scale of this emptiness, consider the density of our own neighborhood. In a region of space the size of the Buta's Void, cosmological models dictate that there should be roughly 10,000 galaxies, forming a rich, active network of gravity and light. Instead, after decades of meticulous scanning, aiming our most sensitive radio and optical telescopes into the heart of this darkness, we have found only a scattered handful of perhaps 60 isolated galaxies, drifting like ghost ships in an ocean of absolute zero. The Buta's Void is a physical manifestation of sensory deprivation on a cosmic scale. If the Milky Way galaxy were violently relocated and dropped into the exact dead center of the Buta's Void, the night sky above Earth would be entirely different. We would still see the stars of our own galaxy, but beyond that immediate localized sphere of light there would be nothing. No fuzzy Andromeda, no distant clusters, just a wall of impenetrable black. In fact, If we lived in the center of the Boötes void, human beings would not have even known that other galaxies existed until the invention of highly advanced deep sky radio telemetry in the 1960s. Our entire history of astronomy, philosophy, and religion would have been a claustrophobic study of our own lonely island, completely oblivious to the wider universe, because the light from the nearest neighboring galaxy would be too faint to cross the hundreds of millions of light years of dead space to reach our eyes. The darkness in the Boötes void is so vast, so absolute, that a photon of light fired from one edge of the void takes 1/3 of a billion years just to reach the other side. It is an architecture of isolation so severe it feels almost predatory. But the final, most devastating blow to our comprehension of scale does not come from the size of the structures or the depth of the voids. It comes from the terrifying realization that the entire system is fundamentally unstable. The map of the universe is not a static document. It is a fleeing phantom. In the early 20th century, an astronomer named Vesto Slipher, and later the legendary Edwin Hubble, began dissecting the light coming from distant galaxies using a process called spectroscopy. By passing the light from a galaxy through a prism, they could separate it into its component colors, revealing a distinct barcode of dark lines that corresponded to the chemical elements burning within those stars. But Hubble and Slipher noticed something entirely wrong with the barcodes of almost every galaxy they observed. The lines were in the right pattern, but they were shifted out of place, dragged aggressively toward the red end of the light spectrum. This phenomenon is known as cosmological redshift, and the physical mechanic behind it is the engine of our existential dread. It is the visual equivalent of the Doppler effect. When an ambulance speeds past you on the street, the pitch of its siren compresses and sounds higher as it approaches, and then abruptly stretches and drops to a lower pitch as it speeds away. The sound waves are physically stretched by the motion of the vehicle. Light operates under the exact same physics. If an object is rushing away from you at tremendous speed, the waves of light it emits are physically stretched out, lengthening their frequency and shifting their color toward the red end of the electromagnetic spectrum. When Hubble analyzed the light from the deep void, he found that nearly every single galaxy in the cosmos was heavily redshifted. They were all moving away from us. But more disturbingly, the mathematics revealed a brutal proportion. The further away a galaxy was from Earth, the more aggressively its light was redshifted, meaning the faster it was violently receding into the dark. This was not a case of galaxies simply flying through pre-existing space like shrapnel from an ancient bomb. The truth of the mathematics is far more bizarre. The space between the galaxies is not an empty, passive stage. Space itself is a physical fabric, and that fabric is stretching. It is generating more of itself every single second. Imagine a loaf of raisin bread rising in an oven. As the dough expands, every single raisin is pushed further apart from every other raisin. No matter which raisin you stand on, it looks as though the rest of the bread is fleeing from you. The universe is not merely vast, it is a swelling, expanding corpse. The unimaginable distances we have mapped, the millions of light years between superclusters, the hundreds of millions of light years across the dead voids, are actively multiplying. The space between our local group and the distant galaxies captured in the Hubble Deep Field is stretching so aggressively that those ancient islands of light are currently being carried away from us at velocities that boggle the rational mind. The architecture of the abyss is not fixed. It is a massive accelerating centrifuge, driving the scattered islands of matter further and further into isolation. And as we stare into the lenses of our greatest telescopes, calculating the raw speed of this expansion, we realize that the true horror of the cosmos is not just its size, but the inescapable, terrifying motion of the dark. This accelerating centrifuge of the cosmos introduces a terrifying mathematical problem, one that forces us to confront the boundaries of our own physics. For decades, the greatest minds of the 20th century operated under a seemingly logical assumption. The universe was expanding, yes, as the echoes of the Big Bang pushed matter outward, but this expansion had to be slowing down. Gravity, the invisible glue of reality, the mutual attraction of 2 trillion galaxies, should act as a cosmic brake. It was a comforting, balanced equation. The universe was thrown outward by an initial explosion, And now the collective mass of everything within it was pulling it all back together, fighting the momentum, steadily decelerating the rush into the void. To prove this, in the late 1990s, two independent teams of astrophysicists set out to measure exactly how fast the universe was hitting the brakes. They did not look at standard galaxies. They hunted for a very specific cataclysmic event known as a Type Ia supernova. These events occur in binary star systems where a dense dead stellar core, a white dwarf, acts like a cosmic parasite, ruthlessly siphoning gas off its living companion star. The mathematics governing these dead stars are rigid and merciless. They can only consume so much stolen matter before they reach a critical mass, an absolute mathematical threshold where the dead star can no longer support its own immense weight. The moment it crosses this line, it detonates in a thermonuclear explosion so violent it outshines its entire host galaxy. Because this threshold is a fixed law of physics, every single one of these explosions burns with the exact same maximum intrinsic brightness. They are the ultimate standard candles of the universe. By measuring how faint these explosions appear from Earth, astronomers can calculate their exact distance with terrifying precision. The astrophysicists aimed their instruments into the deep dark, locating these dying stars across billions of light years. They measured the distances, they measured the redshift to determine the speed, and they fed the data into their models, expecting to see the deceleration of the cosmos. Instead, the mathematics returned a result so fundamentally absurd that the scientists initially assumed their own instruments were broken. The universe was not slowing down, it was stepping on the gas. The equations revealed that the expansion of the cosmos was actively accelerating, driving the galaxies apart faster and faster with every passing second. Imagine throwing a heavy stone straight up into the air, expecting gravity to slow its ascent until it reaches its peak and falls back to your hand. Now imagine that stone leaving your hand, slowing down for a brief moment, and then violently accelerating upward, shooting into the sky faster than a bullet, defying every law of physical intuition. This is precisely what the fabric of our universe is doing. To make the mathematics of an accelerating universe function, physicists were forced to invent a placeholder for their own profound ignorance. They called it dark energy. It is not energy as we understand it in any terrestrial sense. It does not power engines, it does not radiate heat, and it does not interact with light. It is an invisible, repulsive pressure woven into the very vacuum of space itself. And the most chilling aspect of dark energy is its proportion. When the calculations are finalized, the raw luminous matter we can see, the stars, the planets, the glowing gas clouds, the entirety of human existence, and every galaxy we have ever mapped, makes up less than 5% of the universe. Another 27% is dark matter, an invisible gravitational scaffolding holding galaxies together. The remaining 68% of reality is dark energy. Over 2/3 of our universe is composed of an unknown hostile force that is actively tearing the cosmos apart. This relentless acceleration brings us to a physical barrier, a terrifying threshold known as the cosmic event horizon. Because the space between galaxies is stretching, and because there is a staggering amount of space between us and the deepest edges of the cosmos, the cumulative speed of this expansion eventually overcomes the speed of light itself. This does not violate the laws of relativity. No physical object is traveling through space faster than light. Space itself is simply swelling, like the surface of a balloon being inflated. But the consequence is absolute. There are galaxies currently visible in our most powerful telescopes that are crossing a mathematical boundary line. The space between us and them is now expanding faster than the photons leaving those galaxies can travel toward us. It is like a swimmer trying to paddle up a river that is flowing backward faster than they can swim. The light from those ancient stars is still fighting to reach us, but it is moving through a spatial fabric that is stretching away from us at a velocity exceeding the absolute speed limit of the universe. The chilling reality is that the light currently leaving those galaxies will never reach Earth. Never. Those galaxies are effectively slipping over the edge of reality. They will slowly redshift, fading from brilliant white to deep crimson, until their light stretches so thin it becomes invisible infrared, then faint radio waves, until they fade into the absolute blackness of the background radiation. They are being permanently deleted from our observable universe. We are living in a temporary window of cosmic time where the grand architecture of the universe is still visible. If humanity had evolved a few billion years in the future, the night sky would be entirely black. The cosmic expansion would have pushed every other galaxy beyond the horizon, leaving our isolated, merged local cluster stranded in an endless, empty ocean. The universe is aggressively hiding its own vastness, pulling the curtain closed on the physical evidence of its own history. As we attempt to understand the mechanics behind this encroaching darkness, we hit a wall far more impenetrable than the cosmic horizon. We hit the barrier of our own theoretical limitations. The physics we use to describe the universe is profoundly fractured, split into two entirely incompatible languages that refuse to speak to one another. On one side, we have general relativity, the grand masterpiece of Albert Einstein. It is the physics of the macrocosm, the mathematics of the heavy and the vast. Relativity describes space and time as a smooth, continuous, four-dimensional fabric. Gravity is not simply a pull, it is the physical warping, the curving of this smooth fabric caused by massive objects. The planets orbit the Sun not because they are attached to invisible tethers, but because the mass of the Sun creates a deep depression in the fabric of space, and the planets are simply rolling along the curved geometry of that depression. The mathematics of relativity are elegant, precise, and beautiful. They perfectly predict the motion of galaxies, the bending of light around massive clusters, and the grand, slow waltz of the cosmos. On the other side, we have quantum mechanics, the physics of the microscopic, the realm of atoms, electrons, and photons. The quantum world is not smooth, and it is entirely devoid of elegance. It is a chaotic, boiling, unpredictable arena governed by the laws of pure probability. In the quantum realm, particles do not have fixed positions until they are observed. They exist in a smeared-out state of multiple possibilities. Energy does not flow in a continuous stream. It jumps in discrete, jerky packets called quanta. The vacuum of space at a microscopic level is not an empty, smooth fabric. It is a violent, frothing sea of virtual particles violently snapping into existence and annihilating themselves mere fractions of a second later, a concept known as quantum foam. Both of these theories are monumentally successful. They are the twin pillars of modern science. Relativity builds our GPS systems and maps the stars. Quantum mechanics builds our computers, our lasers, and the atomic foundation of chemistry. Yet they are mathematically at war. If you attempt to apply the smooth, continuous geometric equations of relativity to the erratic, jumping, probabilistic chaos of quantum mechanics, the mathematics completely self-destruct. The equations vomit infinities. They produce impossible numbers that correlate to nothing in physical reality. It is as if you are trying to write a single symphony, using the sheet music of a classical concerto superimposed over the screeching, erratic distortion of heavy metal feedback. The two frameworks are fundamentally, structurally hostile to each other. For the vast majority of the universe, this is not a problem. Large objects have enough mass to ignore quantum jitters, and tiny particles have so little mass that their gravitational warping of space is irrelevant. We can use one set of rules for the stars and another set for the atoms, but the universe is cruel, and it contains extreme environments where both theories are forcefully slammed together, demanding a unified explanation that we simply do not possess. The ultimate theater of this physical breakdown is the heart of a black hole. When a massive star exhausts its nuclear fuel, the outward pressure of its fusion engine ceases, and the terrifying inward crush of its own gravity takes over. The star collapses, imploding with such ferocity that it breaks the structural integrity of matter itself. Atoms are crushed, protons and electrons are fused, and the mass of an entire solar system is compacted into a sphere only a few miles across. But the collapse does not stop there. The gravity becomes so intense that not even the ultimate speed limit of reality, the speed of light, is fast enough to achieve escape velocity. The event horizon is formed, the point of no return. But what happens beneath the event horizon? What happens at the absolute dead center of the black hole? According to the mathematics of relativity, the matter continues to crush inward infinitely, condensing into a point of zero volume and infinite density. This point is known as the singularity, but a point of infinite density and zero volume is an absurdity. It is a mathematical error code. Nature abhors a singularity. It is the universe demanding a division by zero, a forbidden operation that shatters the bedrock of logic. At the singularity, the object is so incredibly massive that general relativity must be used to describe its gravity, but it is simultaneously so microscopically small that quantum mechanics must be used to describe its physical state. Both theories are dragged into the same microscopic arena, and together they rip the conceptual fabric of reality to shreds. Time ceases to have any linear meaning. Space collapses into a mathematical paradox. The equations fail, our understanding evaporates, and we are left staring at a physical mechanism that dictates the architecture of entire galaxies, yet whose internal operations remain an absolute impenetrable mystery. This paradox breeds an even more deeply unsettling problem, one that threatens the foundational rules of how reality is recorded. It is known as the information paradox, a theoretical nightmare birthed in the 1970s by the brilliant physicist Stephen Hawking. Before Hawking, it was assumed that black holes were eternal prisons. Whatever crossed the event horizon was trapped forever, adding to the mass of the singularity. But Hawking applied quantum mechanics to the absolute edge of the event horizon, and he discovered a flaw in the prison walls. In the violent quantum foam of empty space, pairs of particles are constantly bubbling into existence, a particle and an antiparticle borrowing energy from the vacuum, immediately colliding and annihilating each other. This happens everywhere, all the time. But Hawking realized that if this particle pair forms exactly on the razor's edge of a black hole's event horizon, the incredible gravitational tide can separate them. One particle is dragged down into the darkness, while the other is violently ejected outward into space. Because energy cannot be created from nothing, the escaping particle must steal a minuscule fraction of the black hole's mass to become real. This process, known as Hawking radiation, means that black holes are not eternal. They leak. They glow with an impossibly faint radiation, slowly bleeding their mass away into the void. Over timescales that mock human comprehension, trillions upon trillions of years, long after the last star in the universe has burned out and the cosmos is nothing but a dark, freezing graveyard, even the supermassive black holes will eventually evaporate, shrinking away until they vanish entirely in a final, quiet flash of energy. But here is where the mathematics of the paradox strike like a physical blow. In the realm of quantum mechanics, there is a sacred, unbreakable law. Information cannot be destroyed. The physical state of the universe is deterministic at its core. If you burn a book, the book is gone, but the exact sequence of the words, the chemical composition of the ink, the structure of the paper, that information still exists, scattered in the smoke, the ash, and the heat radiating into the room. If you possessed a godlike computer capable of tracking the exact trajectory and state of every single atom of smoke and every photon of heat, you could, theoretically, run the physics in reverse and reconstruct the book perfectly. Information is immortal, but if you throw that same book into a black hole, it is crushed into the singularity. And when the black hole eventually evaporates through Hawking radiation, what comes out? Hawking's calculations showed that the radiation leaking out is entirely random. It is pure, dumb thermal noise. It carries no structural information about the book, or the star that collapsed to form the hole, or the unfortunate astronaut who fell in. When the black hole finally disappears, the information of everything that ever fell into it is simply gone, deleted. This is the information paradox. If relativity is right, and black holes evaporate entirely, then quantum mechanics is fundamentally wrong, and the universe is capable of permanently erasing its own history, severing the deterministic link between the past and the future. If quantum mechanics is right, and information must be preserved, then our understanding of gravity and black holes is fatally flawed. Decades of the brightest minds on Earth scribbling complex algebra across endless chalkboards have failed to reconcile this conflict. We are trapped in a cosmos built upon rules we can read, but whose grammar we do not understand. We are passengers in a vehicle where the engine and the steering column appear to be governed by completely different, mutually hostile laws of physics. And yet, the paradox of the black hole is localized. It requires proximity to a collapsed star. There is a far more pervasive mathematical terror woven into the very fabric of our immediate reality. A latent vulnerability resting in the invisible quantum fields that surround us at every given moment. It is the ultimate theoretical barrier, a mechanism by which the universe could suddenly and without warning rewrite the fundamental laws of existence. To understand this threat, we must look at the Higgs field. This is an invisible energy field that permeates the entire universe. It is the physical mechanism that grants mass to elementary particles. Without the Higgs field, electrons would fly apart at the speed of light, atoms would disintegrate, and chemistry would be utterly impossible. The stability of our reality relies entirely on the Higgs field remaining exactly as it is. In physics, systems always seek their lowest possible energy state, much like a ball rolling down a mountain will eventually come to rest in the valley below. For decades, physicists assumed that the Higgs field was resting at its absolute lowest possible energy state, a condition known as a true vacuum. We assumed the ball was resting comfortably at the very bottom of the deepest valley. But when the Large Hadron Collider finally discovered the physical manifestation of this field, the Higgs boson particle, and measured its mass, the resulting mathematics painted a deeply alarming picture. The numbers suggest that our universe might not be resting in the lowest valley. The Higgs field may be perched on a precarious ledge, a localized dip on the side of a much larger theoretical mountain. We are existing in a temporary, fragile state of stability known as a false vacuum. If this is true, the mechanics of quantum probability dictate a chilling consequence, because particles in the quantum realm can occasionally cheat the barriers of physics. A process called quantum tunneling, where a particle simply passes through an insurmountable wall without expending the energy to climb over it. It is mathematically possible for a microscopic fluctuation to cause the Higgs field to suddenly drop off our temporary ledge and plummet into the true vacuum below. If this happens, even in a single microscopic point anywhere in the infinite expanse of the cosmos, it would trigger a catastrophic phase transition. It would create a bubble of true vacuum that expands outward in all directions at the exact speed of light. Inside this bubble, the energy level of the universe changes. The fundamental constants of physics are instantly rewritten. The mass of the electron fluctuates, gravity warps, chemistry dissolves. The very bonds holding atoms together would instantly unweave. This bubble of destruction would not be something we could see coming. Because it expands at the speed of light, any warning of its approach would arrive at the exact same moment as the destruction itself. If it were birthed in the Andromeda Galaxy millions of years ago, the bubble could be washing over our solar system right now, and the first and only indication we would have is the instantaneous, painless dissolution of our physical reality. We are suspended over a mathematical abyss, relying on the fragile, temporary stability of an energy field that could violently correct itself at any given microsecond, pulling the fundamental scaffolding of existence out from under the entire cosmos. The immediate consequence of this unstable, expanding architecture is a brutal realization about our own future. We are culturally conditioned to view the universe as a frontier, an infinite playground waiting to be explored by human ingenuity. Science fiction has deeply ingrained the idea that if we simply survive long enough, if we perfect our technology and master the engines of interstellar travel, we will eventually spread across the galaxy and step out into the wider cosmos. But the relentless acceleration of dark energy dictates a strict, insurmountable quarantine. The speed of light is not simply an engineering hurdle, it is the absolute physical wall of our prison cell. Even if humanity could engineer vessels that travel at a fraction of that ultimate speed, the sheer mathematical rate at which the fabric of space is stretching ensures that 94% of the galaxies we can currently observe through our telescopes are already physically unreachable. Think about the absolute terror of that metric. We can see them. We can photograph their light, analyze their chemical composition, and map their gravitational structures. But they are optical phantoms. because the space between us and them is expanding faster than any ship could ever sail through it. We could launch a fleet today traveling at maximum theoretical velocity, and it would never arrive. The ocean of space is being generated faster than we can cross it. We are locked out of the wider universe. Our destiny, no matter how advanced we become, is permanently confined to the local group, a small isolated cluster of a few dozen galaxies bound together by gravity. Over the next few billion years, this localized cluster will inevitably collapse in on itself, merging into a single massive featureless elliptical swarm of stars, and from the surface of whatever planets orbit within that merged supergalaxy. Any future observers will watch as the expansion of the universe violently pushes every other structure in the cosmos over the event horizon, plunging their night sky into absolute, impenetrable black. But this spatial quarantine is merely the prologue to a much more devastating temporal consequence. The physics of our reality are thermodynamic, and the universe behaves precisely like a colossal engine. Like all engines, it runs on a finite, non-renewable reservoir of fuel, governed by the merciless law of entropy. Entropy is the underlying mechanic of decay, the universal rule that dictates all ordered, complex systems must inevitably break down into chaos, disorder, and equilibrium. Every time a star ignites, every time a planet forms, every time a human heart beats, we are spending the irreversible currency of the cosmos. The universe is not a static painting that will hang in the gallery of time forever. It is a highly compressed spring that is slowly, irreversibly winding down, and the mathematics dictate that there is no mechanism to rewind it. Right now, we are living in what astrophysicists call the stelliferous era, the vibrant age of starlight. It appears eternal and infinite from our tiny vantage point, but in the grand, cold timeline of reality, this era is nothing more than a brief, violent spark. In a few trillion years, the furious blue and yellow stars that define the architecture of our night sky will be completely gone. They burn too hot, consuming their nuclear fuel with reckless abandon. When they exhaust their cores, they will collapse and die, leaving the universe to be inherited by the red dwarfs. These are tiny, smoldering embers of stars, hoarding their microscopic reserves of hydrogen and burning with a faint, blood-colored glow. The sky of the far future will not be a brilliant canopy of diamonds. It will be a dark, gloomy, dying twilight. And even these resilient embers are entirely bound by the laws of thermodynamics. Eventually, their fuel will run dry. They will not detonate in the glorious heavy metal forging explosions of supernovae. They will simply fade out. They will cool and solidify into black dwarfs, massive spheres of hyper-compressed frozen carbon and oxygen, drifting completely invisible in the dark. The cosmic engine will stall. The galaxies, once swirling pinwheels of light and heat, will go completely dark. This marks the descent into the degenerate era. The universe will become a pitch-black, freezing graveyard. The only residents of this endless dark will be the dead husks of stars, rogue planets violently ejected from their decaying solar systems, and the silent, looming predators of the void, the black holes. Without the outward pressure of radiation to fight it, gravity will become the sole architect of the cosmos. The dead planets and extinguished stars will wander aimlessly through the black, occasionally colliding in silent, invisible impacts, shattering into clouds of cold cosmic dust. But even gravity cannot defeat the slow rot of entropy. Over timescales so incomprehensibly vast that the human brain lacks the biological capacity to visualize the number of zeros required to write them down, the physical orbits of these dead objects will fail. Through the continuous emission of gravitational waves, they will bleed away their orbital energy, spiraling inward over billions of years, until they are quietly swallowed by the supermassive black holes lurking at the center of their dead galaxies, or violently flung out into the absolute emptiness of the expanding void. Eventually, the only organized structures left in the entire expanse of creation will be the black holes themselves. The black hole era will be a universe populated entirely by invisible cages of gravity, separated by expanding distances so horrific that no two black holes will ever encounter one another again. And here, in this ultimate isolation, the slow, agonizing process of quantum evaporation will take center stage. The universe will literally wait for these titanic monsters to bleed away into the vacuum. The time it takes for a supermassive black hole to evaporate defies standard human language. If you were to count every single grain of sand on Earth, every drop of water in the oceans, and every star in the observable universe, and assign each one of those 1 trillion years, you would still not be a fraction of the way through the lifespan of these gravitational tombs. But physics is infinitely patient. In the extreme deep time of the future, they will slowly, inevitably dissolve into faint thermal noise. As the very last black holes detonate in microscopic flashes of dying radiation, the universe will enter its final, permanent state, the dark era. The overall temperature of the cosmos will plummet to a fraction of a degree above absolute zero. The concept of matter itself will fail. The fundamental mathematics of physics suggest that even the proton, the heavily bound subatomic particle that forms the nucleus of every atom, the bedrock of you, me, the Earth, and the memory of the stars, has a finite half-life. Without the energy to maintain their structural integrity, the protons will decay. The atomic foundation of reality will unweave, dissolving into a thin, meaningless mist of isolated photons and stray electrons, drifting in an ocean of space that is still expanding, still stretching, driven by the relentless, invisible pressure of dark energy. This is the ultimate hidden consequence of the scale and mechanics of our reality. The universe is not just indifferent to our existence. Its physical laws are actively designed to erase the possibility of any existence whatsoever. In the depths of the dark era, the very concept of time begins to break down and lose its meaning. Time is fundamentally measured by change. It is measured by the ticking of a clock's hands, the orbital cycle of a planet, the decay of a radioactive isotope, or the processing of a thought. But in a universe where all structure has decayed into a perfectly even, uniform mist of freezing radiation, nothing happens. There is no thermodynamic difference between one moment, the next hour, or the next trillion years. Without events, time flattens. The universe reaches a terminal equilibrium, a state of maximum entropy where no chemical work can be done, no energy can be exchanged, and no physical process can occur. This thermodynamic destiny casts a chilling, undeniable shadow backward onto our present moment. It means that the universe is actively working to forget us. Everything we are doing, everything we have ever built, every war fought, every symphony composed, and every scientific truth violently extracted from nature is fundamentally transient. We are fighting a hyper-localized war against entropy, temporarily borrowing the energy of a dying sun to build complex biological structures, to build civilizations, to build memories. But the mathematics guarantee that this is a losing battle. The physical medium required to store information, to preserve the legacy of humanity, or any other theoretical intelligence, will literally disintegrate. The atoms that form our grandest monuments, our digital archives, and our bones will decay into nothingness. The light from our sun, carrying the faint visual ghost of our blue planet out into the void, will be stretched into invisible, flat lines of energy by the expansion of space until it becomes indistinguishable from the background noise of the void. We are trapped inside a cosmic mechanism that is mathematically guaranteed to permanently delete its own contents. Our conscious existence is a temporary anomaly, a brief, highly ordered chemical reaction flaring up on a microscopic speck of dust, insulated from the wider reality by distances that actively mock our ambition. We look up at the night sky and invent narratives of legacy and eternity, assuming our intelligence grants us immunity from the cold equations of the abyss. But the deep physics of the universe do not recognize our biology, our philosophy, or our desperate need to be remembered. We stand at the very edge of an unimaginable precipice. The human mind, built to track the rustling of leaves and the passing of terrestrial seasons, has somehow managed to map the architecture of its own absolute irrelevance. We have peered into the dark, calculated its terrifying dimensions, and discovered that the abyss is not merely empty. It is an active, accelerating mechanism, winding down toward a permanent, frozen silence. There is a profound, paralyzing weight to this realization. For thousands of years, humanity built grand cathedrals, composed sweeping symphonies, and waged catastrophic wars under the comforting, arrogant delusion that the universe was an arena built for our eventual triumph. We assumed the stars were a captive audience, but the cold mathematics of the cosmos have stripped away the illusion of that protective dome. There is no audience. The universe is entirely deaf to our history, blind to our suffering, and structurally guaranteed to delete our legacy. We are permanently isolated on a microscopic fragment of silicate rock, floating in a localized cluster that is actively being severed from the rest of reality. The distant galaxies we capture in our telescope lenses are already phantoms, swept away beyond the cosmic event horizon by a tide of stretching space that no physical vessel can ever cross. The glowing stars above us are aggressively burning through a finite, non-renewable reservoir of energy, counting down the hours to a thermodynamic deep freeze where even the structural memory of atoms will violently unweave. Everything we are, everything we have ever loved or feared, is trapped in a decaying pocket of gravity, suspended precariously over a quantum vacuum that could fracture and overwrite the laws of physics at any given microsecond. This is not some distant theoretical abstraction meant for a chalkboard. This is the exact physical reality of the room you are sitting in right now. The freezing, indifferent vacuum of space is not millions of miles away. It is immediately outside our microscopic layer of atmosphere. The thin shell of gas keeping your biology functioning is a temporary, highly volatile anomaly, a fleeting pocket of heat aggressively opposed by the crushing, infinite scale of the surrounding dark. We are a brief, agonizing spark of biological processing, trapped within an engine of absolute entropy. We are the cosmos waking up for a fraction of a millisecond, looking around and realizing the inescapable mathematical horror of its own decaying geometry. When you step outside tonight and look up at the glittering expanse, abandon the ancient habit of projecting human meaning onto the light. Do not look for comfort in the static. Look instead at the vast, freezing gaps between the stars. Look directly into the black. That darkness is the true, unfiltered face of reality. It is ancient, it is accelerating, and it is patiently waiting for the light to die. The cosmos does not require our permission to be terrifying. It does not require our comprehension to function. And when the final agonizing embers of the very last black hole evaporate into the flat, endless night, there will be absolutely no record that we ever stood here, in the fleeting warmth of the early universe, trying to measure the shadow of the abyss. There will only be the void, perfect, symmetrical, and entirely empty.